Go. Grand Rising and good afternoon, everybody. This is our Melanin and Interstellar Space preliminary presentation. This is by Jordan Tejeda,
Leah Davu,
Neil Rush, Raphael Simon, Taliki Craddock, and
Euphemia Tejeda.
we'll be representing the Black Body Biochem class. Our teacher is Baba Wakesa and Mama Serafina. The school we go to is Educational Institute. The year is 2022 to 2023. And let's dive in. Introduction. Our main topic of research was uncovering whether melanin exists organically within space. This area of research remains relatively uncovered, so our research ran deep. Therefore, in order to find the answer, we figured we must speculate and have inductive reasoning to reach a conclusion. Some examples of our reasoning includes, since the chemical compounds that make up melanin can be found in space, the answer can very likely be found in space as well. Other examples of speculation imply melanin is in chondrites. One of the key speculative points frequently highlighted in this paper is the melanin concerning dark matter or dark energy. But before that, a better understanding of dark matter or dark energy is needed first. Here are some discussion points we have when I'm talking about. When I'm talking about dark matter and dark energy, chondrites, insoluble organic matter, and our goals. Let's go.
what is dark matter and energy? Dark matter is a non-luminous material that makes up 27% of the universe. As it is a particle that doesn't absorb, reflect, or emit light, it cannot be seen directly. Dark matter is only known to exist because of the effect it has on objects which humans can observe directly. Dark energy is a force that is theorized to counteract gravity, causing the universe to expand at an accelerating rate, meaning it causes our universe to expand faster and faster over time instead of slowing down. Dark energy takes up 69.4% of the universe, the remaining amount of dark energy and ordinary matter.
Hot and cold dark matter. There is more one type of dark matter. There is such thing as cold and hot dark matter, even though they are both created from the same substance and particles. Cold dark matter has a lot less energy and moves more of a leisurely pace. Cold dark matter is slow enough that it forms gravitational wells, which permits normal matter to come together between those wells and allows matter to form galaxies. A theoretical physicist at University at Bologna in Italy. Hot dark matter is made of the same particles as cold matter, but a key difference between the two is the speed at which it moves. From this, we can speculate that there's a different types of melanin that run on different temperatures.
Speculation on melanin in space and dark black clouds. The speculation of dark matter in interstellar space and black dark clouds. Black matter is found universally, especially in the amorphous state. All the black matter known to date, some lithosphere and biosphere to the cosmos, generally has the same chemical and physical properties. These include electron paramagnetic resonance, electrical properties, changes in surface properties under effects of an electrical field, the X-ray diffraction spectrum, sensitivity to radiation inducing photoionization and photolysis, explosion, and fragmentation under the effects of laser pyrolysis or fast atom bombardment. Radio astronomy has shown there are organic molecules in the black dust in the Milky Way. Some of these molecules are acetylene or acetylene. Giant red stars also emit enormous amounts of carbon dust into their surrounding space. This implies that interstellar space may look black, not just because of the lack of light or because strong gravitational fields prevent light escaping, and also because of the presence of black matter in the solid state. This matter would be in continual transformation under the action of radiation. Black dark clouds in space may contain black particles formed from benzene structures or heterolytic or photocondensate, like terrestrial melanins. Black patterns in Black particles in general are an interesting feature in the evolution of interstellar space and the biological matter. The, the they are the conductors, which means they can transfer electrical charges from inside the molecular clouds, regulating the chemistry in the ion radical molecule equilibrium. These properties can be deduced from the absorption polarization of the stellar light and spectra of the infrared light emitted by dust. These shock waves produced by the supernova might have the effect, like interstellar particles when they move faster than 25 kilometers per second, of making the black particles in space explode. High-speed ions can cause fragmentation and mixtures of simple products form. Some of the simple organic molecules found in black clouds are also among the products of pyrolysis in the fast atom bombardment of melanin, melanin from here, tyrosine melanin, serotonin melanin, and tryptomine melanin.
A chondrite, a stony meteorite that has not been modified or melted due to the separation from the asteroid. The minerals found in the carbonaceous chondrites can synthesize carboxylic acids, amino acids, and all nitrogen bases, which form ribonucleic acid, considered the precursor of the first living organism. Carbonaceous chondrites are a pristine class of material that forms from the protoplanetary disk and together with interplanetary dust particles from meteorites and comets, and the ultracarbonaceous Antarctic meteorites provide a major source of organic carbon in early Earth. Chondrites contain inclusions set in fine-grained matrix. It is in the matrix that one finds the most primitive materials such as presolar circumstellar grains and organic matter. Melanin is made of organic matter, which we can correlate that chondrite can contain some traces of melanin. And our goals we are trying to achieve. Well, our goal is we want them to feel the existence of melanin is in space is something that can inspire our people to appreciate how powerful our melanin is. We want them to think that there's a melanin in space and that it doesn't just exist on Earth. We want people to do more research, ask more questions about it. We want them to explore melanin in their bodies and see how dynamic it can be in its contributions to bodily functions. We also want them to spread this knowledge to others, making this a cultural goal to take care of our skin a lot better. And we can use too. Many of us believe our skin isn't important, and we want to change that tragedy of being a Black person. We want to change the view on melanin and show them how powerful we are. There's our resources, and thank you for learning and watching.